There is an interesting write-up on two studies finding that schizophrenia can be related to circadian rhythms. In the first study from the British Journal of Psychiatry, the researchers found that there was a disruption in sleep in people with schizophrenia that was independent of the effects of medication being taken to treat the illness. These included phase changes in the circadian rhythm. In the second study, the researchers investigated the function of the SNAP25 gene in a murine model. The SNAP25 protein is a component of the snare complex which mediates the release of the contents of intracellular vesicles. Vesicles can act as a storage structure within the cell. For instance, they could be involved in the release of neurotransmitters from neurons into the extracellular space. When the SNAP25 gene was not expressed, the researchers found that the circadian rhythm was altered. The circadian rhythm is very closely related to a structure called the suprachiasmatic nucleus. The suprachiasmatic nucleus is a structure in the brain which plays an important role in the circadian rhythms. In other words, it's the body's biological clock. There are a series of other biological clocks in the body which regulate activities according to time, and the suprachiasmatic nucleus sits squarely in the center of these clocks and is thought to be responsible for regulating the body's rhythms. So if we look at the diagram, there is a sagittal section through the brain, and what this means is that it's like we're looking at somebody from the side. So on the left side of the diagram is the eye, so that's the person, I suppose, looking forward. You can visualize it a little easier. And on the right side of the diagram is the back of the brain. That's where the cerebellum, the little brain, sits underneath the brain. So on this diagram, the red dot marks the spot. That's the suprachiasmatic nucleus, and it sits on the optic chiasm, hence its name, the suprachiasmatic nucleus. Supra meaning above, and the chiasm being the crossing of the optic nerves. Now, what do I mean by that? Well, if we go back to the eye, you'll notice that there's a line connecting the eye to the optic chiasm, and that is the optic nerve. The optic nerve transmits all the visual information from the eye to the brain. So the optic nerve is an incredibly important structure for us to be able to see. Now, the optic nerve would, both optic nerves would cross over the optic chiasm, and then seated above them would be the suprachiasmatic nucleus. And this is quite interesting in terms of the structure, because if you want to know the time and you don't have your wristwatch, then you would have to kind of gauge it from the environment. You know, you would look at the sun rising, or the sun setting, or getting an indication of how light or dark it was outside. Now the brain does this automatically. You don't need to think about it. It just does it. So it's a very smart mechanism. And this is what's operating through the suprachiasmatic nucleus. That's why it's directly above these two incredibly important optic nerves. And the next quite interesting feature about the suprachiasmatic nucleus is that it sits squarely in the centre of the hypothalamus. And the hypothalamus is a structure within the brain which coordinates a number of physiological functions or activities in the body. So it's a kind of control center for many of the body's activities, and it initiates signals to which it sends to the pituitary gland, which then sends further messages around the body to different structures. So it's kind of coordinating or initiating fairly important physiological functions related to things like sleep and appetite. So now you can see the kind of almost brilliance, if you would like to think of it in evolutionary terms. I suppose brilliance isn't the right word to use, but when we put all of this together, it does seem incredibly efficient. And what it's doing is picking up the information from the environment about the lightness and darkness, and sending it straight to the areas of the body that need to pick up on these signals, and that's kind of why we might feel hungrier at certain times of day, and why we might be more likely to feel tired in the evenings, and why we might, for instance, get jet lag after going on an aeroplane. So the suprachiasmatic nucleus is the area where it's all happening. And in some conditions, these incredibly important signals about rhythm and about the environment don't get out to the other structures, and this can be associated with illnesses possibly, and this is an area of research that is ongoing. The researchers found that although the suprachiasmatic nucleus was functioning, there was a disruption of the signals between the suprachiasmatic nucleus and other organs. They suggest that with sleep disturbances occurring in many mental illnesses, alterations in the suprachiasmatic nucleus's signals should be investigated further and may offer novel lines of inquiry for therapeutics. In a study of 3,725 same-sex twins, researchers found that the risk of autism in one twin was significantly correlated with lower birth weight. The researchers were using a cut-off limit of a 15% difference in birth weight between twins. They found that lower birth weight was associated with a 13% increase in the risk of autistic spectrum disorder, that's 1-3, for every 100 grams reduction in birth weight. However, the research also shows that other factors are likely to be important as well. The Department of Health has stated a commitment to the 3 Million Lives project, which aims to improve the lives of 3 million people over the next 5 years through telehealth and telecare. There's a very interesting piece by Thomas Lin in the January the 16th edition of the New York Times, which is looking at the open science movement that is quickly taking place. And Lin looks at ResearchGate, which is an online portal that is bringing scientists together. Researchers have identified a correlation between the citation rate for a sample of Science and Nature articles and their citation count on Google Scholar and the Web of Science. However, the researchers note it is a correlation and causality would need to be investigated further. So in essence what they're saying is that the citation index of articles in very high prestige science journals, which is a very important factor for scientists in their careers, is related also to some of the online citations on very widely used tools such as Google Scholar. So that might be very helpful for scientists, but until causality is examined, it's difficult to draw any conclusions. You can find these stories on the Amazing World of Psychiatry website, which can be found at theamazingworldofpsychiatry.wordpress.com. There are a few things on the website that you won't find here, for instance videos by other people or links to videos by other people, and also there will be hypertext links, so you'll be able to navigate to the source for these news items.